Okay, we're doing week 2, Intro to Numbering System. These are some examples that you'll be able to use for our quiz at the end of the week, or maybe toward the beginning of week 3. We'll see. So we'll deal with whole numbers, and this one will be we're going to be using a division by 2 algorithm here. So this is going to take a decimal number, and this number is going to be 12. And we'll show a couple of methods, but this one will be division by 2, as I mentioned, and you'll be doing this sequence here. Okay. To check that your conversion is correct, you'll do your check right there. Practice some other numbers, like any number that you want to try. Let's maybe try 13 or 14. And we can represent those by hexadecimal, which we'll get right into shortly after this. We're going to try to keep this under at least 10 minutes, hopefully. There's a lot of material here, but a lot of reference for you to work on your own as well, okay? This is another way. I kind of like this method. You don't have to adopt this. You can do whatever you want. This is taking the decimal number 156 and going to this algorithm as well. Go through your math to make sure that this is equal to 156 as well, as you learned up in this section. You just need to go a little more left. Let me fix this. Again, this is another method as well, doing double dabble. And when we get into different shift registers, we'll be maybe doing a few of these just to reinforce these concepts. This is the table method, and they essentially use the same method as number 1, but then you'll use this sequence as well. Your favorite fractions. Let me go down and fix this header. So you have 2 parts. You have your 3 and then your 0.25. So let's, we know that the 3 is going to be a binary 1, 1, right? So let's deal with this 0.25. So again, this is how you sequence through that. And you're reading the integer parts from top to bottom. So when you combine this, you'll get 11.01. Okay. Try to do a few of these on your own. Maybe you could put 0, 1, 1, or maybe a 1, 0, 1 for your decimal. Use the same methodology. This will be decimal to hexadecimal conversion. So you're going from a decimal to a hex. Okay, so we'll find out that the decimal 10 is a hexadecimal A. Well, I have a lowercase a, so same thing. Decimal 15 will be a hexadecimal, decimal 15 will be hexadecimal F. And then a decimal 17 will be a 0. Sorry, this is incorrect. This would be a 17 when you do this all out, okay? So this is an error here on my part. So the decimal 17 is a 0x11 in hex, a decimal 17 again, okay? Alrighty. Again, as we described, the hexes go all the way from alpha A to F. So the easier way to convert these decimals to a hex is to use the division by 16 method. So for number 17, we'll go through the sequence. Okay, so let's take this number 18 and go through it a little bit more in detail here. Sometimes students kind of get this a little bit kind of mixed up, but they finally get it through a few examples, okay? Again, when you do that, you're going to divide by 16. Your result will be 1 with a remainder of 2. And then we're going to go through breaking these up so you'll see how this really arrives at the equivalent of a hex. Okay, so this is what you kind of want to study for that. I'm not sure if you work this out, you'll work a few examples out, you'll get this, but let's take this 12 again. So we have a hex 12, which we are trying to just read over this as well, and this may have not made much sense, but we're going to go over it a little bit more in detail here. So this is the correct way to convert a 12 hex to decimal. And so we'll group it in two groups, 16 to the 1 and 16 to the 0. And as you see, we got 16 to the 1 and 16 to the 0. So if you multiply this out, this becomes 16. And then this is essentially 1. So 2 times 1 is 2, and you end up with 18. Okay. So we'll practice this. This is I'll probably have 1 or 2 of these on the quiz. So if you work these out, these won't be any problems. But again, I may ask that you go the other way. But for this, I'll say this text got mixed up here. Okay, so 20H hex in decimal is 32. In binary, it's 1100. So check that to make sure that's correct. This is another example here. This is 20 to the 16, and we want to go from hex to decimal. And make sure this is correct. And we ultimately will find out that we may want to just do things in binary and then go either to a decimal and or a hex. Sometimes students find that a little easier to deal with in terms of the math. But it is, the logic's the same in terms of following the algorithm. And again, we found out that this 18 decimal was a 12 in hex. Okay? And here we have some answer sheets for you guys to study for your quiz. And if you have any additional questions or problems, please email me. I'll help you if this doesn't really make any sense, but it should at this point. You guys got your math down, so it's It's really math, really. Okay, these are most of the ones that will be on the quiz. I'll just pick a couple, maybe one fraction, um, and then maybe decimal to binary, etc. That's going to be pretty doable at this point. We're not really doing any extreme binary math at all yet. Okay, then we'll get to kind of introduce this in week one, just a very simple binary addition. Now for our lab, as I mentioned, we'll be doing a 4-bit adder. So you can see this one right here is represent this as register A and B. And this one will be good because we will have a carry out in our lab. So this should show the carry out. Same with this guy, the 8 plus 8 will have a carry. These are some of the questions that will be possibly on the lab, I believe, if I remember. Some of these are from the text as well. So again, read your text and prep. And I'll assign a few problems as homework too, and then we'll have something similar in the discussion post for this as well. Okay. Now again, this is sort of some tedious stuff here, but again, I'm not going to ask you to do stuff like this. This would be kind of extreme at this point. We don't really have to go this far, but what I'd like you to take a look at and remember is the unsigned and signed numbers. So unsigned numbers here are described as being non-negative, and the assigned are both positive and negative values. And we'll get more into this when we do our adder and subtractor circuit, which will be another lab somewhere down the road. And again, you guys have done this pretty good, the decimal, the fraction. Okay, so that's it for, I was trying to keep it under 10 minutes. I went over close to 14. But again, go over this and do your best. Any questions? Let me know. Okay. Thank you for your time.